In today's video, we are going to be looking at infrasound. So, in a nutshell, infrasound is sound with a frequency lower than 20 Hz. It's called infrasound because it is below the frequency of the human hearing range. But as it turns out, some animals can hear and actually communicate via infrasound. So you could say infrasound is like the secret language of elephants and whales. It is also, though, the sound of many natural disasters. Earthquakes, volcanoes, avalanches, they all release infrasound waves. But luckily, scientists can monitor the levels of infrasound to predict if one of these natural disasters is about to happen. And so we can all run, or at the very least, buy insurance. Today, we are going to focus specifically on the waves that are released by earthquakes and how they help us to understand the structure of the Earth. So, these waves that are released are called seismic waves, and they come in two different categories, S waves and P waves. And these waves have different properties. S waves are transverse and P waves are longitudinal. I kind of remember this by the fact that an S sort of looks like a transverse wave. S waves can only travel through solids, whereas P waves can travel through solids and liquids. Again, S for solids. Yeah, not my best work. And finally, S waves travel slower than P waves. So I know what you're thinking, that's all great. Actually, you probably weren't thinking that. But how do we use these waves to find the structure of the Earth? Well, let's have a look at a picture of what S waves look like travelling through the Earth. You can see when an earthquake is set off here, no S waves make it to this side of the Earth here. That's called a shadow zone. And the reason for that is, well, S waves can't travel through liquids. And since the outer core of our Earth is liquid, that stops any of the S waves reaching this shadow zone. The curve of the S waves is to do with refraction, or your waves bending slightly, and it's because the density of the mostly solid mantle varies slightly. Okay, time for the P waves picture. Right, at first sight, this looks quite a bit more complicated, but no need to panic. Let's have a look at these kinks first. These kinks, or sharp changes in direction of the waves, are due to refraction. This tells me that the waves have travelled through two different materials. This bending of the waves that travel through that liquid outer core means that you get these two shadow zones here and here for your P waves. You do detect P waves on the other side of the Earth because P waves are able to travel through liquids. So using all the information together of S and P waves, scientists can begin to build a picture of the internal structure of the Earth. Okay, hope you found that helpful. Please make sure to like and subscribe and download the notes. Thanks for watching.